Alright, today I want to introduce you guys to the trig ratios, and trig is short for trigonometry. Trigonometry, which is really the study of triangles. And so, we left off with studying 30, 60, 90 triangles, and we called them 30, 60, 90 because that's what angles they had in them. And we studied their ratios, and we found out that their ratios were 1 to root 3 and 2. We also talked about 45, 45, 90s, and those had a different ratio. So, 30, 60, 90s don't just have to have a 1 to root 3 and 2 ratio. They could be twice as big, or 3 times, or 4 times, or 5 times as big. But no matter what size they are, the ratio of the sides remains the same. And so if you notice that the ratio of this side to this side, 1 to 2, is the same as this side to this side, the short leg to the longer leg. And so what we can do is we can talk about, let's compare two sides at a time, and they will always have the same ratio, as long as you have a right triangle and you have one angle the same. Because last chapter we talked about similar triangles, and so right triangles always have at least one angle in common, and if you have a specific angle, then every single 30-degree angle will have the same ratio between all the sides, and every 40-degree angle and 50-degree angle and 60-degree angle, as long as we have a right triangle, because you will always have the 90 and one other, making the third one something that you know. And so what we do is we use words to describe the sides' relative position, and we talk about them being relative to an angle. And so if we talk about the 30-degree angle, we have automatically this side right here, the 2, is called the hypotenuse, because it's across from the right angle. And so in this triangle, the 4 would be the hypotenuse because it's across from the right angle. That's nothing new. But relative to the 30, if we circle the 30, we have words adjacent and opposite. Now, the 1 is going to be the opposite because it is opposite the 30-degree angle. And then the root 3 is going to be adjacent to the 30-degree angle because it's next to, it's adjacent. Now here's the confusing part, because there's always going to be two sides that are adjacent. But the not so confusing part is that the fact that the hypotenuse is always the special adjacent one, and so one of the adjacent sides will always be special, will always be the hypotenuse. So root 3 we call the adjacent side. Now that's only if this is the angle we're talking about. If we are talking about the 60, and I'll use this triangle, just if we're using the 60, then all of a sudden the longer leg, the 2 root 3, is the opposite side. And all of a sudden, which one is adjacent? Well, we've already labeled the 4 as being the hypotenuse, and so this is the adjacent that we'll just call the adjacent side. So what we can do now is talk about, well, if we compare the opposite to the hypotenuse, that ratio is 1 to 2. The opposite to the hypotenuse in this one is also opposite as the 2 to the 4. So 1 to 2 and 2 to 4 has the same ratio. And so we're going to use words to describe when we say opposite to hypotenuse and adjacent to hypotenuse and opposite and adjacent, and those ratios. Those are called the trig ratios. And so this is going to look overwhelming, and I'm hoping to settle it down. And so we have 3 trig ratios that we're going to introduce. There's also 3 other ones, but these are the only ones you need right now. So there's one called the sine, and the cosine, and the tangent, and we abbreviate those with SIN, COS, and TAN. Now we still say tangent, sine, cosine, and tangent. And so even though this looks like the word sin, it's the shortcut, it's the abbreviation of the word SINE, so we pronounce it sine. I promise you I will mock you if you say sin. But it'll only be in jest. Now this letter right here, it's a Greek letter called theta, and it acts just like an x would usually. It's a variable that we use to represent angles. And so instead of writing 30 degrees, we could just talk about theta. Now, sine is the ratio between the opposite and the hypotenuse. And so if we said, what is the sine of 30 degrees, the opposite over the hypotenuse is 1 over 2. If we said, what's the cosine of 30 degrees, that would be the adjacent to the hypotenuse, and the cosine adjacent root 3 divided by 2. And if we said tangent, tangent is opposite over the adjacent, and so that would be the opposite, 1 over the adjacent, root 3, so 1 divided by root 3. We'll practice this here in a second. But this can be very, very overwhelming for the first time you're seeing it. And so you'll say, I'm never going to learn this, I can't possibly remember it all because there are so many different things. And so somebody more wiser than I said, let's take the first letter of all of these, the S and the C and the T, and the O and the H and the A and the H and the O and the A. And they said, let's remember so, ka, toa. And so you may have heard people talking about this. So, SOH means the sine, which is the opposite over the hypotenuse, O over H. Cosine is A, ka, adjacent over hypotenuse. And tangent, toa, is opposite over adjacent, OA. And so this is how you can remember it. Some people just write it straight out. I just thought this was an easier way of organizing it for right now. And so we can ask questions in several different ways to just start us off. And so I can ask you, what is the sine of 60 degrees? And you would say, well, that is, sine is opposite over hypotenuse because it is the SO part of the SOHCAHTOA. That's the first part you need to think of. And then 60, the opposite side to 60, is the root 3, and the hypotenuse is across from the right angle, and so it's 2. And so the sine of 60 degrees is root 3 over 2. Now I could ask you what the tangent of 30 degrees was, and that would be toa. And so toa, and so again, let's put our 30 in here. Toa is opposite over adjacent. And so now our opposite side was the root 3 before. But now our opposite side is not going to be the root 3. It's going to be opposite of the 30. And so this is the opposite in this case. And this is the adjacent in this case. Now the 2 is adjacent as well, remember, but the 2 is the hypotenuse. So we have 1 divided by root 3. Which we could then rationalize, root 3 over 3. We just multiply by a form of 1. 1 times root 3 is root 3. Root 3 times root 3 is root 9, which just happens to be 3. And so that is the tangent of 30. You don't always have to have the angle measurement for you to be able to do the ratio. So the next one says, what's the cosine of B? Cosine of B is so ka toa, so I'm going to write the ka, which is adjacent over hypotenuse. Now they said cosine of B, and by they I mean I because I created this problem, but we'll just call them they. So this is B, and adjacent to B is this side and this side. This side is across from the right angle, so this is our hypotenuse. So the 3 is the adjacent side, because it's not the hypotenuse. So we want 3 divided by something. Now what is the something? Well, the something is whatever the hypotenuse is. And we don't have it. But we could figure it out because it's a right triangle, and I know that a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. So 9 plus 16, so 25. And so some of you may have recognized the Pythagorean triple right off the bat, and that's okay. Some of you didn't. But so we got 5. So then the hypotenuse is 5, and we get 3 over 5. Done and done. Last but not least, let's try one more. It's the tangent, let's say the tangent of G. Sorry, let's say the tangent of D. Tangent of D is the TOA, which is opposite over adjacent. Now, if we use D, the opposite side is the 3. And the adjacent side, well, 8 is adjacent, but it's also the hypotenuse, so it's not the adjacent side. So this is the adjacent, and unfortunately we don't know it again. So just like the last problem, we could use Pythagorean theorem. Careful in setting it up, because this time we have the hypotenuse, so it's going to be 3 squared plus something squared, I'll call it b squared, equals 8 squared. So we get 9 plus something equals 64. So if you subtract the 9, 64 minus 9 is 55. And so I take the square root of that, and so I get square root of 55. So tangent is 3 over the adjacent side, which happens to be root 55. So I'm going to multiply by root 55 over root 55 and get 3 root 55 over 55. So if you missed a few videos ago, what I just did is called rationalizing. And I did it before as well, but what it does is it gets the square root out of the radical. The square root out of the denominator. While not essential, because this 3 root 55 over 55 is the exact same thing as the 3 over root 55. They are equivalent, but people a long time ago preferred this because you wouldn't have to divide by a decimal, you just have to divide by 55. So it's a bit old-fashioned, but it's a good skill to still know. So what in the world do we need to remember about today? Well, you've got 3 sides, which are all relative to the angles, and you can remember sine, cosine, and tangent ratios by remembering SO, CA, TOA. Know how to spell it, and so that's why I say SO, CA, TOA. I use a big A vowel to talk about the CA so I can remember it's C-A-H. And that's how I remember it. Good luck as you continue learning about sine, cosine, and tangent.